Hello everyone, welcome to the discussion of SQL Server. In this session, I am going to talk about the concept of schema and indexes. I'll also talk about some other functionalities and components that we can use in SQL Server. Now, the concept of schema and indexes are very important in terms of working with day-to-day queries in SQL Server. I'll also talk about how we can use some techniques to optimize the query performance in SQL Server. So let's understand these topics with some simple examples.
Fine. So what is a schema? Now, if you can see over here that for this particular database for human resource, you can see there are a lot of tables which are listed under the table folder. Now, over here, we can see that for each of the tables, there is a prefix written as DBO. Now, what is this DBO? DBO is a schema under which the table is created. Now, the question is, what is a schema? Now, we all know that database consists of tables, views, stored procedures, field, record, functions. Now, all these objects of a database follows a particular structure through which we can implement the security features, through which we can implement the authentications level to the end users. Now, these implementations of authentications or security is done to the schema. If you talk about the definition, a schema is a structure through which you can see it is a structure by which all the tables, views and stored procedures are defined in a database. Now the question is how we can create this kind of schema. Now DBO means database owner. This is the default schema that we get while creating a table in a database. Now you can see there are schema like management, there are schema like payroll. Now if you want to see the schemas where the schemas are listed, you need to come down in the security folder. In the security folder, you can see that we have folders like users, we have folders like roles, we have folders like schemas, and under this schema, you can find this DBO schema, you can find this management schema, you can find this payroll schema listed. Now, the question is how we can create this kind of schema and how we can create a table under a schema. So the next example, I'll show you how we can create a schema like DBO, management, payroll, and how we can create a table under that particular schema. The way we are seeing it over here as DBO.departments, management.employee manager tree, payroll.employee payroll. Now, to create a schema, we follow an approach of data definition language and the data control language. Now, if you remember, in my initial discussion, I talked about the four important commands, right? The data manipulation language, data definition language, data control language, where we use the different types of approach to work with the table structure, the table data, or the data query language. So we'll use such commands to create a schema, and we'll also create a table under that particular schema. Now, how to create a schema? For example, I'll take a new query and I'll write a simple statement over here, create schema, and let me name that particular schema as secure audit, and I'll use the word authorization. Now this is the steps that we follow to create a schema. DBO, that's it. And under this particular schema, I'll define a table called create table EMP audit, or I can use uppercase for this for the table name, EMP audit. And as I've defined a table, I need to also define a column along with the data type and the acceptance of the null values. So let me define the column as SID employee. The data type will be int, and let me not allow any null over here. Now that I have created a table, let me define how we can use the data control language to to define the security level that I want to provide for each of the users who access this particular schema. Now to define the users, what I have to do, I have to first create two users and then I have to assign the security roles for them. Now the question is how we can create users and then assign the roles. Now what if I execute this particular schema? So you can see this command has been successfully executed. Now if I come over here and if I refresh this schema, you can see there is a secure audit schema has been created. And if I go up over here and if I refresh my tables or database and if I expand my table, you can see the security audit.emp audit table has been created over here. So under the schema secure audit, we are able to create a table, and in that table we have a column called SID employee with the integer type as int, and that will not accept any null value. Now what if I want to assign some users for this particular schema with a specific roles in terms of authentication? How we can assign a users for this? So for assigning a user of this particular schema, I need to first create a user. So I'll just come down to the security folder again, and under the users folder I have to create two users. I'll right click on new user, and I'll use the user type as SQL user without login, so he doesn't have to provide any credentials. And I'll create a user as, let me create it as staff audit, and I'll give the default schema over here as, let me give it as DBO only. And I click OK. So you can see first user is created. Let me create another user. Right click, new user. The login type, make it without login, and let me make it this user as business user. And I click OK. Now I created two users over here. Now what I want to grant few roles to them, some authorization to them. The first user that I create, I want to grant that user that particular user can select from that particular schema. So I can come over here to this particular new query option, and I can write grant select on schema, and the schema name is secure audit, secure underscore audit, and the user will be let me take the first user, staff audit. The second authorization that I want to give is I want to deny the select action. I want to deny the select action for the second user. So if the second user cannot perform the select option on this particular schema, so I will write deny select on the schema secure audit to the business user. Now if I execute it, and now if I come down over here and if I refresh this particular database once more, now if I come to the security folder and if I come to the schema over here, and if I click on the secure audit schema and go to properties, and if I click on this permission option, you can see these two users has been added to this schema. And for each of the user, you can see the permission that has been granted. So over here you can see for this particular schema, the select permission has been denied. And for the staff audit user, the select permission has been granted. So we have added two users for this schema with a different permission level, where one can select the data from this particular schema and the second one cannot select the data. You cannot manipulate the data, or you cannot query the data from this particular schema. Now this was a fair idea about the schema, how it creates and what roles we can play over the schema. Now what we can do, we can understand some of the functions that we can write in SQL. So we will work on some functions We'll work on some loop functions, how we can use a loop to create a table and to retrieve a data into the table. And also we can see how we can use some functions like some length functions or some trim functions like left or right functions. We can also see how we can find the index of a character. We'll also see how we can use a replace function in SQL. So the first function that I'm going to show you is how to find the length of a particular column. So let me take an example for that. I'll take a new query, and as I'm using the human resource database, select, I'll use a length. So what is the length function does? It calculates the length of a particular column that is supplied as a part of that particular, as an argument or as a parameter for that particular function. So I'll select from employees and what I want to select, let me select the employee number and let me select the last name. And what I want to do, I want to use a length function on the last name column, and I want to show that particular column as length of name. Now if I execute this particular option, you can see the length of each of the name in the last name column. Now if I want to select star from employees, you can remember the first two length 7 and 6, right? So if I select, so the first length, the length of the last name of the first row is 1 2 3 4 5 6 7. Okay, and the second one was 6. 1 2 3 4 5 6. So we are getting a correct value in terms of calculating the length of the last name column, where we have choose a different column name to show the length. I'm getting a question over here. Guys, this database is already uploaded in the drive. This human resource database and all, everything is uploaded. Pinak, you have to go and check your dashboard. The link is already uploaded for the sample data set for SQL. It's long back. It's before the SQL session only. I guess I have updated all the sample data set. You can just download it from there and you can use it. The next function that I'm going to use is a left function. Now you all know we have used left function in Tableau also. We have used a left function in Power BI also. Let's see how a left function works in a SQL. I'll take a new query and I'll write a simple query where I'll be using again the employee table. So I'll write select from employee table, and what I will select, I'll select the employee number, I'll select the first name, let me select the last name also. And what if I use a left function on the first name, and I want to project it as an initial. Now let me execute this particular, I'm going to give a comma over here. Now what if I execute it? So you can see that I've got the first name. So what has left function done? It has extracted the first letter G, B for the second name, and it has created a new column with the first initials. Now what if I were to create a column using the initials for the first name and the last name? Something like this. What if I go for an option like this? I'll get a new line and I write a function again using a left function on the first name, but I will extract the first character. I'll use a operator over here to concatenate these two particular value of first name and last name. So what I can do, I can take a dot and I'll again use a plus sign to join the last name, and I want to use it as a short name. Use a comma over here, and now if I execute it, I can see that
that the select function has extracted the first letter from the first name and it has actually joined the last name to get a short name for each of the employee in terms of the employee number, name, first name, last name, initial, and the short name. So this is how we can use some of the functions within a query. Some string function you can say within a query. Now what if I want to use a function like character index to find the index position of a character in a column. Now for that, let me take a new example. I'll take a new query and this time I'll use the current location table. So select star from current location or employee location I guess. Now what I want to find the character index in terms of the, I guess let me select the current personal because I'm looking for a specific column over here, current personal. So over here in the current personal, I have a column called current location. Now I want to use the char index function to find the position of n in a current location column. So let me see how we can use this particular function. So I write current select star from, let me use this particular option. So I can use select star from current personal where you can use a function called char index. It's a built-in functions to search or return a particular position of a character in a int value. So I'll use this particular function char index and I'll search a character position n dot in a column called current location. And I'll use a operator over here which is more than 0. Now if I execute this particular query, it has returned me the position of n for the current location column. So we are able to see that for the North Vancouver, for the current location column, it has returned that particular value with this char index. Now what if you want to replace this n with North? I don't want to see this n. I want to replace this n with a word called North Vancouver. So for that, I can use another function called replace. Now what I can do, I can modify this particular query as select emp number current location, and in the current location I want to replace the n dot with North. And I want to show it as a new location, as a new column, so as a new or updated name from the current personal table where this char index function will execute. Now if I execute this particular option, you can see that I have got a new column with the updated name as North Vancouver for each of the current location where it is n dot Vancouver. Similarly, in case of, so we can see that how we can use some of the inbuilt functions in SQL to find some of the information from an existing table that we have in the database. What if we want to apply a loop function in SQL? Now people who are not from programming background, they might be wondering what is a loop. So loop is a type of an option, or you can say it's a type of a procedure that we define in any, say loop is basically used for in programming languages, but you can also use loop to perform a task repeatedly. Now if you want to type a number from 1 to 10 for example, now each time you cannot write a number individually, right? 1, 2, you cannot input a number individually into a database by using an insert function, by insert 1 in column 1 or like this. You cannot insert a number. What if you want to perform this task repeatedly? So you have to take the help of a loop
function. So what does loop do? You start the loop and it will run till this particular condition is fulfilled. Now if you tell the loop, okay fine, you have to run 10 times, and every time you run you have to print the numbers with the increment of 1. So the first time the loop runs, it will print 1. The second time the loop runs, it will print 2. Now the question is how to create a loop and how to tell that particular loop that okay fine, you have to print 1 to 10 for me. You have to run or execute 10 times, and every time you run you have to print a digit for me. For example, now what are the things that you need to take care of? First, you have to create the loop. Second, what you have to tell the loop that okay, you have to run 10 times. Third, you have to tell the loop that every time you run, you have to print an increment of one number. So you have to define the condition for that particular loop. So let's see how we can work with loops in SQL. So I'll take a new query for this. And first, let me show you a very simple loop, and then I will show you how we can use loop to create different types of options. Like for example, we'll create a table, a date table using a loop, where we'll be defining the number of weeks and we'll be defining the each week with the difference of 7 days. So first, let us say a simple implementation of a loop. So I'll write a variable. Now you know how to declare a variable. Yesterday I showed it, right? I'll write a declare a variable. For example, let me name this variable as counter. And the data type of this variable will be int, which is equal to 1. Now I will define the loop. I'll use a while loop over here. The while loop will say this variable counter that you have to run till you reach 25, and the counter starts from 1. So you have defined the initial position of the counter as 1. Now this while loop is saying this variable that okay, you have to run till you reach 25. Now you have to use the begin word to start this loop, and when the loop will start, it will print this variable counter. Oh, till here I am sure you are clear. So you have defined the variable which will start from 1. You have defined the loop over here which is telling this variable that okay fine, you have to run till 25, you reach 25. Now every time you will run, you have to print the value of this variable. So the first time if the loop runs, it will come and check the counter value is 1. 1 is less than equal to 25, right? So it will print 1. Next time the loop runs, the counter value will change to 2. But how will this particular counter value will change to 2? We have to also set that particular command also, so that every time this counter gets print, this variable value gets print, the value of the variable will increment automatically by 1 by writing the next command. So we'll tell set this counter equals to counter plus 1, and then we'll end this loop. That's it. This is a very simple implementation of a loop. Just an example. The next example will make things more clear for you. So we have defined a variable with a value, the starting point. We have defined the loop that it will start from 1 and it will run till 25. And every time it will run, it will print the value of that particular variable. And after printing the value, it will increase the value of the variable by 1. And now if I execute this particular, you can see that I have got a result which is run till 24. If I write it less than equal to 25, let's see how it works. It will run till 25. So let us understand. So first the value of counter is 1. 1 is less than 25. Yes. If it is yes, it will print 1. Then the value will increase. 1 plus 1, 2. Now counter will become 2. So 2 is less than 25. Yes, it will print 2. Then it will increase to 1. That is 2 plus 1, 3. The counter value is 3. 3 is less than 25. It will print 3. So you can easily print 1 to 25 using a loop. Now how we can use this loop function? Create a table. That table will consist 2 columns. First, the week number, and second, the start date of that week. Now, for example, week number 1 will start from, for example, 1st Jan 2019. Then week number 2 will be 8 Jan 2019 because 1 week will be added to the first week. The third week will be 7 plus 7 plus 7, that is 8 plus 7, that will be again the next week, 15th maybe, third week. So how we can create a week wise? So there will be 52 weeks for example, and each 52 weeks have a start date. We can do this kind of options using a while loop. How? So let's take a new query for this. So let's define this particular operation into 4 steps. The first step will define the table and the column names of the table. So we can write as a, how we can write it? We can write simple, declare date table. You can write it as a date, or you can write as table date like this. So define a variable and a table which will consist of 2 columns. So one we can name it as week number, and the data type should be int, and week date, the data type should be date for this. So the first step is done. We have defined a variable and a table with 2 columns. The second is defining 2 variables. The first variable will hold the value of the week number in integer format, and the second variable will hold the start date of the week. So I'll come to the next line and I will declare 2 variables. Declare the first variable as number, whose data type will be int, and it will hold an integer value 1. This is the first week of the number, that is the week number which will start from 1. The second data type, the second variable will hold the first week. So we can name it as week first in a date format. So data type will be date, and let me start the date as 2020 12 31st. So we have declared the variable over here also. So second part is done. So the first variable will take care of this week, which is in integer form, and the second variable will take care for the date, which I want to be start from 2020 December 31st. Now what will happen? The output will start from the first week of Jan, because the loop will execute and will add 1 week to this existing week, the starting week that I have defined over here. So let's work on the main part of the loop. Now we will define the while statement. We'll come over here and write while this variable num that I have defined should be greater than -1. So anything -1, greater than -1, that will be 0 or 1, the loop will execute. So I have defined the loop rules, and now let's define the loop body. The loop body will start with begin, as I showed you earlier, and it will tell that insert into the variable date, where we have defined 2 columns, wnum and week date. And we'll select the variable num and we'll add a new week with the help of date add function, which takes 3 arguments: the week, the variable, the number of the week that we have defined through the variable, and the variable week first, which consists the date. And we'll increment the value of the week by 1 every time. So if week starts from 1, the second week will be 2. So num equals to num plus 1. Now we can end the loop. Now if I execute it, so data has taken a week from, and if I execute it, let me see how it works. Okay, so okay, and then I insert. The selected instance contains fewer items.
The number itself must match with the number. Week number, week date, date I has taken. Number date table, date, select. So let me check how it runs. What if I select star from table name? Sorry, an error. Just a minute, let me check the week number. First week number int has been declared. Int equals to 1 first. Number while number equals to this one. Okay, let me get a condition where this condition gets fulfilled is greater than 52, then you have to break it. And now if I use this, just let me check, guys. I'm missing some things over here. So date. Declare the date table. Define. Yes. That's what I was not getting. What I was missing over here. Okay, fine. Let me if you execute. Yes. So you can see that I have used a while loop statement to define the week number and the week date for each of for each of the week number there is a new week that has been added which starting from 7, 14, 21, 28. So 7 days are getting added for each of the week number. So this is how we can use a while loop. So I just missed a comma over here. That's why all these things happen. Fine. So the thing is that let's understand this particular code. So first I have defined a table over here. I have defined the tables with 2 columns, and then I have defined 2 variables which will take care of all the initial values. So the first variable take care of the initial week as 1, and the second variable has taken care of the starting week as it should add 1 week to the existing start date. Now what I have defined the condition of the loop that should be always be in positive, not in terms of minus or anything which is there to -1. And then I have defined the body of the loop which will insert into the table under the column week number and week date using this particular variable and this date add function which will add 1 week to the existing week date that we have given, and every time a week is added the week number will increment it by 1 and it will run till it reaches 52 weeks and then it will automatically break. So you can see with the help of a loop function, we have just created a table which consists of the week number and the week date. So this is how we can use a week number or a while loop to work with the table level where you can insert data. We can also select or extract the data. The next example that I will talk about is also again a discussion on some operators like union, all, intersect. What is the difference between intersect and inner join? Now let us first understand with the help of an example. I'll take a new query and I'll take a table like department table. So I'll write select star from department and I execute it. So you can see there are 11 columns, right? Now what if I again execute this particular table? I select this two and you can see I've got 2 results. So 2 different results showing me the same output. Now what if you want a union? I need to apply union operator between these 2 tables. Consider this table as 2 different tables. Now if I use union over here and I execute it, it will always return me all the unique values from both the tables. But if I use union all, it will return all the duplicate values. It will not filter the duplicate values, but will return all the columns from both the tables. You can see 1 to 11 from the first table and 1 to 11 from the second table. So if I remove the all, it will filter the duplicate values. Now if I use all, it will not filter the duplicate values from both the tables. These are kinds of operators which you can use. The same like we have intersect and inner join. The inner join, what it does, it will only give the columns which matches the matching criteria. But if you use an intersect, it will also give the same matching columns, but it will always filter the duplicate, and inner join will fail to filter the duplicate from both the columns, both the tables. The same way we are using union and union all. You can see over here. So these are some operators that you will come across while working sometime. Now these terms are very extensively used by the database administrator when they work with table structures and all. But at the data analyst level, you will mostly be using this kind of operations for joining or selecting some particular rows from the table on the basis of some use cases. Now, after all these things that we have learned till now, one important thing that come into mind again from the database administrator point of view, that how we can improve the query performance. Now, to be very frank, as a data analyst, I have never worked on query performance because I'm morely into the extracting and data and querying the data to get it in the Tableau or get it in the Power BI. But okay, I have got a request that I need to speak about some query performance. So in order to improve a query performance, now I'll leave it to you. I recommend you guys to explore these particular options for improving query performance. We can use the concept of index. The index is a very important concept in SQL Server database understanding, where we use index option to increase the performance of a particular query. Now there are a lot of questions that comes in the database industry, that how we can improve a query. Now why does the performance of a query get hampered? This is the first question you need to identify, and then we need to work on the solution part. Why the query process becomes very slow? There are various obvious reasons for a query to run very slow. First, it can be the size of the data that we are handling. It can be the design of the database that can hamper the query performance. It can be the busyness of the server that hampers the performance of the query. The server may be very busy. You're querying a request due to the business of the server. Your querying is running slow. You might be handling a huge amount of data where you are trying to extract a particular information to a query, but the query is running very slow. Or it may be a bad database design which is created by the database administrator, due to which you are facing this issue. Now the question is, let me give a real world example. Now we can take care of the query of performance with the help of index. Now what is an index? Now for understanding index, let me go back to an example on a daily life. Now when you read a book, you can see there are a lot of chapters in a book, right? Like in the beginning of each book, there is a section called index, where you can see the page number related with each of the topics that have been discussed in the book. So what do? You directly come to that particular page, an index page. You see the topic name, you see the corresponding page number, and you directly go to that particular page without wasting your time by querying through all the pages and all the chapters of the book, making the process a bit slow. You directly reach that particular page and you start reading the intended topic that is available in that particular page number. The same concept we use in SQL Server, and what we call it's called index. Now let me show you a simple implementation of index, what we do at the backend by the database administrator. So I am not a database administrator, but I have tried to make this thing very simple for you. What I can do, let me write a small query over here and let me try to explain you how it works. I'll take a new query. For example, let me write select, and I'll write count the distinct ID from the column SID employee. Let me name it as payroll, or you can name it as pay EMP pay. I can take it from this table. Let me see. payroll dot employee payroll. And let me define a condition where, let me check a column from here. So let me take a pay date column. So where pay date, if I execute it, I might be getting a error, not getting an error, I'm getting a value as enp pay underscore 0. Now, if I select this particular command, you can see there is a option over here, just beside this particular parse option, that is estimated execution plan. Now, if I execute this particular option, you can see some values are being generated over here. Now, out of these values, this particular, what you can say, these parameters that are generated below, if you focus on the last parameter, there's an option over here called table scan, which shows 96% in terms of cost. The cost over here is not the cost related to the monetary value. The cost over here is the parameter on which a table is scanned. So you can consider it as a time, or you can consider it as a number of what you can say, memory uses that we are taking. For example, just make it very simple for you. So you can see over here it's 96%, which we, in terms of the database terminologies, it's not a good option. Let's consider 96% is not a good time or a good resource or a good memory allocation that system is taking to scan this particular table. So what is the goal? You have to reduce this 96% to any other, the lowest of value where the table time, the table scan value reduced from 96% to any other next lowest value. So how we can do that? We can do that with the help of index. So there is a folder over called index, right? Now what we can do, we can use this particular folder to index this particular table that we are using over here. Now how can do? I can right click over here, click on new index. Let's go for the non-clustered index option. And you can see that table name over here, employee payroll. Now what I can do, I can change the index name into test 1, for example. And to index this particular table, I have to use these two options, index key column and include column. So in the index key column, let's add a column as pay date and click on OK. And include column, let's add a column as SID employee, for example. So we're indexing this particular column, pay date. I want to include this column for indexing SID employee. And if I click OK, you can see the indexing has just taken place over here. And now if I again execute this particular column, and if I check the execution, you can see the cost has reduced to 22% with the help of this index, which was earlier 96%. So you can see the CPU cost, this estimated number of executions. You can see how the system resources are being used for executing this query. Now I will recommend people who are interested in improving the query performance to understand this index part of querying your queries, or writing your queries, or executing your queries in a SQL Server. So this is the roadmap that I can give you where you can start to understand how we can improve the query performance by using the index options. There can be a lot of implementation of index like clustered, non-clustered. So you can use this kind of options as the execution option to understand it more further, to understand how we can improve the query. But make sure whenever you're dealing with kind of query performance, keep three things in mind: the database design, the server productivity, and the amount of data that you're using. And you should always relate to the index in the real world that we use while reading a book, and how we can implement that particular index in terms of improving the query performance.